Hello everyone. Today we will discuss about the dynamic lift. Dynamic lift is the force acting on a body due to its motion through a fluid. So this is discussed in case of one is aerofoil, which is the basic principle for lifting an aeroplane. Second is Magnus effect, which I'll discuss in detail later on, but this is actually the curved path followed due to the lateral pressure difference while moving through a fluid, when a spinning ball moves through a fluid, right? So first is aerofoil. So for explaining the aerofoil, I would like you to visualize a wing of an aeroplane. Suppose you have your aeroplane which is moving this way, and this is the wing of the aeroplane. So this is the wing of the aeroplane. The part which is shown here is the cross section of the wing of the aeroplane. So if you look at this, this is the nose of the aeroplane, back side of the aeroplane, and this is the wing of the aeroplane whose cross section I have drawn here. So if you look at the cross section of the aeroplane, so the shape is like this. This is a peculiar shape which is broader at the front, more curved at the front, and pointed at the back, comparatively less curved. And this upper side is having more curved part, that means more distance is there, and this is less curved. So if you look at this, this is more curved and the lower part is less curved. We know then that when an aeroplane moves through a fluid like this, right, these wings will cut the air, and these air layers will be cut by this part of the wing, and these air layers, when these are cut, these again will meet at the back of the wing. So these are the layers of the air which are shown here. So when it cuts the layers of the air, these layers will again join at the back side. So what will happen, since this distance is more on the upper side, so the velocity of these layers of air will be more on this side. So I can say that here this distance is more, so you can say velocity more. So I can write here that this distance is less, so velocity is less. I hope this is clear. Now if we apply the Bernoulli's theorem over here, because this is an application of Bernoulli's theorem. So Bernoulli's theorem we know that it is P plus half rho V square plus rho G H is equal to constant, right? But if this is considered at nearly same level, then we can neglect the term containing height. So this will be neglected due to same height. So what will be our expression for understanding this? Our expression will be P plus half rho V square is equal to constant, right? So this sum is to be constant. So if we say that here on the upper side, if we mark this as the upper side and this one as lower side, then we can say that on upper side velocity is more. So if velocity is more, this term will be more, so left term will be less. So you can say that pressure is less. So if we talk about lower side, velocity is less, therefore pressure is more. And we know that the fluid moves from higher pressure to lower pressure side. So if we mark this over here, that here the pressure is more. So velocity is less, pressure is more, right? So here the velocity is more, therefore pressure is less. So we can say that this lift acts in upward direction. So that's why the aerofoil experiences an upward lift due to low pressure on upper side. Similarly, if we consider a ball which is simply spinning, so simple spinning will drag the layers of the air around that ball, and these layers will be taken by this ball this way, and these layers will be taken by the ball this way. So if we mark the direction of the air layers on a simple spinning ball, so we can mark the arrows as shown for the layers of the air. Now if we look at this case, when the ball is moving forward only, so for this forward motion, the layers will be dragged backwards. So this way there will be the direction of these layers this type as shown in the figure. So if both spinning and horizontal motion, or you can say the linear motion, is occurring, then what will happen? The layers will be dragged like this, but on the upper side and the lower side, due to the same and the different senses of the motion of the ball, what will happen? Here the velocity of the ball sense is this way, right side, and here the layers are moving backwards. So we can say that the resultant velocity will be less. And here the sense of spinning of the ball and the layers is this way only, same side. So you can say that the resultant velocity is more. So if again we apply the Bernoulli's theorem for same height, P plus half rho V square is equal to constant rho GH neglected for same height, right? So again, when velocity is more, pressure is less. So you can say कि on this side I'm just writing upside and downside. So velocity is less on the upside, so you can say that the pressure is more, and when the velocity is more, pressure is less. So I'm writing here separately. So on upside, velocity is less, so pressure is more, and downside, velocity is more, so pressure is less. So we know that the fluid moves from higher to lower pressure side. So it will cause the motion of the ball to move from higher to low pressure side. So this ball will curve this way. So I can write here that the ball will follow a curved path from high to low pressure side. So what is Magnus effect? The lateral pressure difference which causes the ball to take a curved path with curved side on the higher pressure side. This effect is called as Magnus effect. So Magnus effect the curved path followed by a ball due to its spinning and linear motion through a fluid with curvature on more pressure side due to lateral pressure difference. This effect is called as Magnus effect, right? So I hope you have understood this thing. That's all for now. Have a nice day.